Hi friends, in our last session we have seen integration of knowledge database and machine vision. In today's session we are going to see interoperability in a smart automation. This is Razan Kakbi and I welcome you all for lecture series of Industrial Internet of Things. So let's begin. So topic is interoperability in a smart automation. Now what is interoperability? So we would say it is a connection or we would say a collaboration of a people, cyber physical system and a manufacturing. So that is called interoperability. Okay, and that is for a smart automation. Okay. Now as we know the digital revolution that was even it's called a industry 3 that was started in the year 1970 if you remember, right, and that was discussed in even in our subject industry 4.0. So during that phase the industrialization and technological advancement were quite slow down, right. So various devices and digital devices have been developed such as we would say PC technology, right. Computers has been established, then a concept of boolean algebra has been established, that is AND gate, OR gate, NAND gate, right. Then binary system has been established, 0101. So that was happened during our digital revolution, that is our industry 3.0. Now when we connect our industry 3.0 with our cyber system or internet, then it is going to contribute to industry 4.0. Okay, now that concept of Industry 4.0 has been developed in recently in the year 2011 by a German government, right, as we all know, and it is also called as Industry 4.0 or Fourth Industrial Revolution that has triggered by advancing the technologies. So we can say that the outstanding success of leading the corporation specialized in the use of digitized information such as we can say Google, Facebook, eBay, Amazon, which all shows the potential of a mass information, especially the potential in analyzing such amount of data. Now, all these technical giants has a large amount of customer data, right? So they are going to contribute to a big data. Now, what we need to understand over here that how machine-to-machine interaction is going to take place. So the key features of machine-to-machine interaction is the merging of a digital and a physical process. The benefit which is coming out from a digitization and a big data related technologies can only be successfully exploited for the usage in an industrial environment. So that can only be achieved if the representation of a physical object and the generation of a data melds together, that is combines together. So obviously the approach is to obtain a representation of a physical object in a form of digital twin. As already mentioned, as a cyber-physical system, or a more precisely in a domain of production, cyber-physical production system. So in a domain of production, the cyber-physical system is called as a CPPS, right? Or even it's called a CMS, cyber manufacturing system. Okay. Now we have to understand several reasons which are going to provide a holistic management needs to be established, which are going to give an idea that why information management is required or why it is required to be established. So you can clearly see that three important points are given. That is because of increase in flexibility in a complex production systems of manufacturing companies by enabling in-process planning, reconfiguration and control. Then after we require decentralization of the responsibilities in terms of planning and execution. Now, as we already know, and this has been discussed previously, that decentralization means what? That is, the control has not to be centralized at one place. It has to be located at different place, so the different levels of management can operate it. Top level management, middle level management, and a shop floor person can easily operate the machines. Right. So that is a decentralized control system which has to be provided in our industry 4. Okay, now even it is required to be enable the methods of learning and usage of enhanced process knowledge directly between the machine and throughout the entire information and communication supply chain of a manufacturing enterprise. Okay, now also if we understand this, so there are a couple of interface standards and standardization efforts that has been carried out to meet these requirements of a IT infrastructure in a modern manufacturing enterprise. Now, starting the development of a industrial Ethernet to more sophisticated solution based on protocols which allow extended information modeling. Okay, so that is an important thing. Now, what are the common representative for this semantic approach? So we can say now, as we already know, the semantic approach means a systematic or a well-structured approach. So the techniques are data distribution service has to be provided for a real-time system, that is DDS has to be provided, and second interface is a OPC-UA, that is called Object Linking and Embedding for Process Control Unified Architecture. So that is a standard which has been a well-known successor and within the industry reality well established OLE for a process control standards. Okay guys, now let's move on. Now the next topic which we need to see is enhancing resiliency in production facilities through a cyber physical system. Now, to understand this, we need to see the market trend which is prevailing and which is used for a customized product, and second, a technology trend which is used for the cyber physical production system. So obviously that whatever product which we are going to develop or manufacture is totally based on a customer demand. So we have to first of all measure and gauge the demand of a customer. Okay, and as per that only we can manufacture the product. Okay, so we can say that whenever we are going to produce a goods or a product which is required by the customer, we have to check or we have to determine the various requirements for our industry or for our factory. That is, we know that what we require, we need to check about the components and the tools which are available. Then we need to check the storage and transportation means. Okay, along with that raw materials, that how much raw material is available, then finished and semi-finished products are how much, that is a storage is how much, then all the construction parts, as well as we would say that how many employees will be needed in order to manufacture the particular type of a component. Okay, it is the most important analysis which we have to do while producing a new product. Okay, now the customer demands are subject to continuous change. We know that a change will take place over the years as a passing years, so we have to be more focused that it is going to form a buyer market driven by the customer demand and not offers. Okay, so based on a buyer market we can clearly say that cost of the product is also definitely going to increase. Now the customized product for a manufacturing company of a highly industrialized state, for example Germany, are becoming more important enabler to exist in the face of global competition. The inherent complexity of this product places a new demand to those companies and their factories. Now let us see the technology trend for a cyber physical production system. So we can clearly say that in development and design, models of a construction parts to be produced later mostly focus on a geometrical, substantial and functional aspects. Okay, so we can clearly say that in a production, other models of product to be manufactured come to the foreground, such as the method description, operating instructions of our numerically controlled machines and their programs. And from a sales perspective, the quality and a cost model plays a most important role. Okay, that we need to consider while designing. Okay, now models of availability of machines and facilities are also needed to be added, which can be utilized for production planning or the simulation of a production process. Now that means there are not only various product models of a company but also various models of its resource, that is employees, machines, facilities, technical building services, etc. are required for the manufacturing of a product. Okay, so for all these models has to be established. Okay, now let's move on and see the next slide. Now we are going to see the resilient factory as a response to the given trends. So the given trend, we know the customer demand and the technological trend, and based on that how the resilient factory will be provided or produced. So we can say that resiliency is often applied concept in many scientific areas. So basically in the field of psychology, and later it is modified by biology, system theory and sociology. So in general we can say that resiliency is the ability of a system to recover from external perturbation and return to its initial state. Now, in the organization theory, the term resilience is already in a widespread use. It is used widely. Now, what is that? So, what does that mean? So, in that case, resiliency is the immanent ability of an organization to maintain a stable state in face of a continuous external perturbation and occurrence of a unpredicted major events like a natural disaster. Okay. Now we can clearly say that your resiliency of a production system, especially in a connection with the industry 4, is defined attributively with a term like persistence, adaptability, agility, redundancy, that is repetitiveness, and learning capability and a decentralization. Now what is flexibility? So we can say that flexibility is an ability that is an implied resiliency characteristic. Adaptability exceeds the concept of flexibility. What is that? So it considers explicitly the functionalities to dismantle or expand, while flexible production systems solely provide a certain range of tolerance. Okay. Now, additionally, energy and resource efficiency form a substantial characteristic of a resilient factory. Remember that. So, this reflects that adaptability and robustness should not be enforced with undergoing excessive use of a resource. So, we can say that through those four characteristics, we define the resilient factory within a framework of a Industry 4.0. Okay, now let us move on and we need to see the chart. So this represents the characteristic and abilities of a resilient factory. Now what is that? So adaptability. That includes a large scale to small batch has can be produced, right? The factory has to adapt that. Then quick start of production. Okay, fast ramp up. Okay, now robustness is required, so there is a second characteristic. So it includes a safety in operation, safety against the disturbances, security against attacks. Okay, and energy efficiency and resource efficiency. So these are the characteristics and abilities of a resilient factory. Okay, now let's move on. Now what is the objective of a resilient factory? So we can say that through the characteristic defined in a previous topic, the resilient factory enables an increase of productivity in comparison to the current state of art, which has been described in this diagram. You can clearly see. So this represents the increasing productivity as a main goal of a resilient factory. Now, in an initial diagram, you can clearly see that in a circle, productivity is shown, and there is also waste of productivity, which has a large area coverage. Okay, at a present case. Now, when we applied the resilient concept, that is, we applied the objective or characteristic of a resilient factory, that is adaptability, robustness, energy, and resource efficiency to this factory. So it is going to convert it into a Industry 4.0, and definitely the waste of productivity will be reduced. Okay, all the operations which we have discussed, that is safety in operation, fast ramp up, all will be included, and which is going to lead to increment in a productivity of the industry. So you can clearly see that it is written adaptability, robustness, as well as energy and resource efficiency represents the substantial requirements to better exploit existing resource and thus reduce the wastage. Okay. Now in today's production facility, productivity is wasted in many ways. Unplanned perturbations of machinery and equipment results in a delivery delays and wastage. Right. Even we have our ideal time, that is a downtime of a machineries and equipments, which also contribute to the non-productive time, right? So this includes what? So this includes a setup process of a flexible production system. Okay, in addition to that, productivity loss also takes place according to the Toyota production system, that is called Mura in Japan. So this is a Japanese term. Okay, that means unevenness. So these are the losses which are caused by disharmonious capacity utilization within the context of a production control. Okay, this describes the losses within a work process. On the other hand, it refers to the employees who produce errors due to the physical or psychological overload. Okay, so whenever an employee gets an overloaded with a work, so because of a physical error or psychological load, it will lead to a error. Overload, and on the other condition, it refers to the machinery with long waiting lines due to inaccurate production planning. Okay guys, so in today's session we are keeping up till here. In our next session we are going to see communication and networking in industrial Internet of Things. So till then, stay tuned and thank you all.